Duodata is one place where business stakeholders can find what a metric means, how it's calculated and sourced, who owns it, and how it's implemented across all your data platforms. In Duodata, we have what's called a metrics ontology, where metrics are a first-class citizen. That metrics ontology are metrics, slices, reports, and sources. Metrics are the first-class citizen, which means we start there. What do you want to measure? In Duodata, I'm able to provide a clear and clean interface where the business can name the metric, tag it, and in this case, we have an example of a private equity firm where we've tagged for compliance reporting. I can also provide a plain language description, attach synonyms, and then I can define how that metric is calculated and have one of two categories of metrics I can place that in. One is a source data metric, which comes directly. It's a measure that comes directly out of the source. And then I have what's called a formula. In Duodata, I can define the metric as a mathematical formula in a simple build screen. That's going to be a mathematical abstraction away from any code, but can be understood by agents and simply forward engineered into multiple code bases such as SQL or Python. I'm also able to apply a unit of measure. In this case, that unit is a multiple, which I define with X, and I also assign a time grain. I will connect slices to this as well. Slices are like dimensions. We give it a simpler name. We think that's a more business-friendly name to call it a slice, but that's going to show me how I can view each one of these metrics. The group bys for each of the aggregates per investment status, per portfolio, per fund. I can also apply governance tagging to it, so I'm able to move it through a life cycle from draft to proposed, approved, implemented, obsolete, and I can also define these categories in that life cycle customized to my organization. I'm able to define releases and attach each version of my ontology also to implementations and releases of the engineering of that ontology. I can also assign business and technical owners. Importantly, in Duodata, I can also assign value drivers. This is where I'm actually applying a customized value to the lineage and the buildup of this metric. So I'm saying here, this particular version of EBITDA and this particular version of net leverage ratio actually drive the value of my multiple on invested capital. I can also define reasons for why it drives it. I attach my metrics also to reports, and very importantly, I'm able to see the lineage of that metric. How is it built up from the source to other metrics and eventually comprising the metric I have now, multiple on invested capital. The entire lineage and of the calculation logic is in Duodata. So that's the first component, metrics. Secondly, I have what are called slices. Slices, like I alluded to earlier, are essentially the dimensions. These are how I'm going to view each one of my metrics, but I also want a definition which allows me to define these concepts, really the nouns that are in a lot of my ontology, and apply the same kind of governance I would to the metric. I can define which source it comes from, apply synonyms, and then an important part of the slices, we can also assign a slice hierarchy. I can see what the rolls up to is for this, and when I assign certain slices, I will also assign the slices that they roll up to. All the governance pieces that I mentioned earlier for metrics are also available. We want to treat this with the proper life cycle and versioning and ownership, and then also I see the attachment to my metrics and my reports. And that brings me to reports. Reports are the logical groupings of metrics and slices. They're essentially the semantic groupings. I'm going to govern these groupings, describe them, tag them, and manage them just as I would those other components that are part of them, the metrics and slices. And also, I'm going to be able to attach what we call questions this report answers. This is where I can actually give hints to the AI and even provide my users who are interacting with this as sort of a lightweight catalog, some examples of questions that these semantic groupings would answer. Finally, the fourth component are my sources. Sources are the IT reality. They're the business systems of record where I'm pulling the data for calculating my metrics. I want to describe those. I want the business to see and understand what that is through the interaction with the ontology, and also see where this particular source is implemented in metric slices and reports. So those are the 4 pieces of the metrics ontology in Duodata. So I want to take you to the governance piece here and also talk about platforms. Duodata is called Duodata because it has, number one, this very simple business surface to interact with those 4 simple concepts for the metrics ontology. But the other side of Duodata is the technically capable side. That's where we're able to connect to the various platforms and actually anchor our ontology and anchor our implementations in the ontology that Duodata is providing. So here I've defined a Snowflake platform. This is my medallion architecture within Snowflake, my bronze, silver, gold, where I've forward engineered the concepts in my private equity calculations and metrics and all the slices associated with it. I forward engineered that into my platform, and I've also anchored into it, and I'm now governing it using my ontology. I have the details about that so that I can sync this up with the platform. And you ask, how might I sync this up with the platform? We are going to do that through Git. Everything that we define in Duodata is going to be in code. So we can either export it as YAML or JSON. In this case, I have defined all of my metrics and slices in a YAML format, and I'm pushing version by version to Git and connecting and actually creating each release of my ontology and storing that in version control in Git. I'm able to define a Git integration with that repo. And then on the other side, on Snowflake, on the other side of this where that platform is defined, I have also connected the repository so that I can pull those definitions into my Snowflake environment and actually deploy those into semantic views. So I want to show you that really quickly. Here I have what's called my Duodata Snowflake Agent, which has 2 main functions. I'm able to capture schema. So I have this place where my Snowflake medallion star schema, this database is where my Snowflake medallion star schema has been deployed, and I've connected to that, and I'm able to actually sync up my DDL, or my actual objects, columns, and relational constraints, and pull those into the Git repo, where also I've put my Duodata definitions. So the same repo is a place where on the platform I'm able to capture schema, which is what I'm syncing now, and also implementation details about that schema. So very quickly in Duodata, I want to show you here where that same MOIC metric is implemented and actually mapped into my Snowflake platform. So I've been able to capture that, and actually if I look at the large view of this screen, I can see in code how this implementation has been captured here within the YAML, and I can see the details about that particular metric as well that will be sent to my repo. We also have the OSI version of these, which is now the Aussie Apache project, which is a multi-vendor project to standardize semantic definitions on platforms like Snowflake, Databricks, and tools like dbt. I can also capture the dbt MetricFlow version of that as well. I'm going to come back to the Duodata version because that's what we're going to use in our platform. So I'm actually going to hide this right now, and I'm going to show you quickly how we can actually take those semantic definitions and begin building them in a Snowflake semantic view workflow. So I've pulled in an actual report, which is a semantic grouping, this fundraising and IR dashboard, and I've pulled that into Snowflake, and now I can begin this workflow that builds the YAML and eventually deploys it to my Snowflake environment. So I'm forward engineering these semantic concepts from Duodata into metric slices and the relational components that are needed in the database to then connect and place a semantic view over my data and then be able to chat with it. I can do the same thing in Databricks. So here in Databricks, I have an app that I can run. This is the Databricks Platform Agent that allows me to do the same thing where I can capture the definitions from the catalog inside Databricks, and I can capture tables and then sync those to my Git repo. Once those are synced to the Git repo, I can do as I did with Snowflake. I can map on those definitions, connect them to my metrics and slices, and then from there pull those definitions with the mappings into Databricks, govern them, and go through a workflow where I can actually create the elements necessary for creating a metric view in Unity Catalog. And that can be deployed and is also expressed in that YAML format that is specific to Databricks for metric views. Again, the calculation logic, the dimensions, the relationships are all there in the metrics view for allowing those interactions by agents and chatbots with the data. So Duodata has both sides. We have the simple business interface for the business to maintain and date continually and own really the business ontology and what we call the metrics ontology through those 4 core concepts. But we also have the capable back end that can be used for deploying and connecting to the various platforms. And of course, this is all code stored in Git, so there are many other use cases for solutioning around that code with agents, but we have built these 2 particular integrations as native apps that run in both Snowflake and Databricks.